Hi everyone, today I'm gonna solve the homework that I gave you last week. So the homework here, which is multiple torque, how can we find the maximum shear stress? So the question said is we have the pipe has an outer diameter of 40 millimeter and inner diameter of 37 millimeter. So that means this is the shaft. We have the outside diameter equal to 40, okay, and we have inside diameter which is equal to di equal to 37 millimeter. So if it is tightly secured to the wall, that means this pipe is fixed at the end, at the last end of secured to the wall at point A, and we have 3 torques are applied to the pipe. So we have 3 different torque. We have 80 Newton meter to this direction. We have opposite direction 20 and 30. Determine the absolute maximum shear stress that developed in the pipe. So what he needs the maximum shear stress. So first of all, because we have the 3 torques, I can't find the shear stress until I can find the maximum torque. Okay, so maximum torque I cannot expect it from the figure. I need to draw the torque using the section method and then find the maximum torque. So first of all, because we have 2 different directions, we have this direction and other direction, let's be consistent for the direction. So I'm going to assume this direction is going to be positive. Of course, the opposite is going to be negative. Okay, so 80 Newton meter, which is positive, 80 Newton meter is going to be positive. So my drawing is going to be up to 80. After this point, we don't have any torque, so it's going to be continue to be 80 until we can find there is another torque applied in opposite direction, which is negative 20. So 80 minus 20, that drop my torque to 60. Okay, after this point we don't have anything on the pipe, so 60 is going to be continue until we got 30 positive. So this make my drawing up to 90, then continue to 0. Okay, so who make this one to be 0? Of course, here at the fixed end we have moment, okay, which is, it should be 90, negative 90, so make my drawing going to be 0. Okay, from this figure, what can we see? The maximum torque that applied on the pipe is going to be 90. Okay, so you cannot use 80 or 60. It has to be 90. Why? Because he needs the maximum shear stress. Maximum shear stress, of course, if we have maximum torque. So I'm gonna type or write the equation. So we have tau maximum, which is the shear maximum, is gonna be T torque maximum times C, which is the radius, or let's call it R maximum, divided by J. Okay, let's define the parameters of this equation. T maximum, which is the maximum shear that applied to the on pipe, which is 90 Newton meter. R maximum, it is the maximum diameter divided by 2. Which is the maximum diameter? Of course, is going to be 40. So 40 on 2 is 20 millimeter. Okay, what about J? So J is the polar modulus of polar moment of inertia of the shaft, which is equal to J equal to pi divided by 32 dO cubed minus di cubed. Okay, so which is pi on 32 dO, which is the outside diameter, as we said it's 40 power 4, minus the inside diameter is 37 power 4, and this gonna be equal to 6.73310 power 4 millimeter power 4. This is J. So tau maximum, the shear stress maximum, is going to be the T 90 Newton meter, because all we have in millimeter, so change the meter to millimeter. So I'm going to time this to power 3. This became Newton millimeter. Okay, times R maximum, we said it's 20, and J is 6.73310 power 4. This, the answer is going to be 26.7 Newton per millimeter square, which is 26.7 MPa. Okay, thank you.